clinic. I'm doing was I told you. I'm doing anesthesia practice and also doing pain practice, but not so much. So I'm here to run this radiofrequency.
I'm Dr. Joy Mundi, assistant consultant, spine surgery. I have 6 years experience in pain management and spine surgery.
So how are you working?
Myself, Dr. Abhishek Tripathi. I'm from Fortis Hospital, Radiofrequency.
Knees. Now I came for shoulder, spine and hips.
I'm Dr. Madhu Shoghavin, coming from Lannis Hospital in Madurai. I'm a pediatrician and general medicine.
Yet to start the pain factors actually.
I'm Dr. Aishwarya. I'm from Chennai, Omutra Government Medical College. I've been doing 1 year fellowship in Daradia, and we are doing pain and palliative care in my primary institution in Chennai.
It is from Kanyakumari Medical College. Yet to start the pain practice. I started my pain fellowship in Daradia.
I'm Dr. Bhaskar from Indian Air Force. I'm an anesthesiologist and working in Air Force Hospital, Jorhat. I'm doing 1 year with
Dr. Shruti from Harvard. I'm a start in pain area. Just finished the PhD.
Dr. Jayashri from Davangere, Karnataka, doing 1 year fellowship.
One of you told that we are doing radiofrequency. You is also doing. So others are completely new in radiofrequency. Have you seen the procedures or?
Yes.
Okay. So most of you have seen the procedures. And are doing any interventions? Any of you? No. Okay. But you must be knowing that radiofrequency is an advanced procedure, and it is not recommended that who are not doing any interventional procedure, be a surgeon or a physical medicine or an anesthesiologist, doing an open surgery and doing an interventions are completely different. So it is always to be remembered that interventional procedures have to be done only by who are well experienced with other interventional procedures. Particularly, most of the interventional procedures are preceded by diagnostic work. Say for example, if I am planning to go for a facet joint injection, that must be preceded by facet joint diagnostic work. Diagnostic work means it can be a diagnostic radiograph work or it can be a diagnostic intraarticular joint. So, who are thinking that okay, I will be doing radiofrequency procedures, he must be first be competent enough to do the other interventional procedures. Like, I started radiofrequency procedures in 2005. And that time there was no radiofrequency machines available there. So when I contacted this people from US, so they wanted that okay, we cannot sell the machine to someone who is not competent enough in the radiofrequency procedures, because ultimately this is some destructive procedures if the needles are not, and it is not an open procedure. So it's percutaneous, you cannot see the nerves when you are doing it. So if the needles are wrongly placed, so it can have a disaster. So we want to see your certificates, workshops, how many you have attended, and then only we can sell the machine to you. So that means why I am telling the story, that those be you are the surgeon or be you are an anesthesiologist or main medicines or a PML. So my advice to all of you, that first start doing the other interventional procedures which is non-destructive. That means do a steroid injection, do a local anesthetic injections before thinking of or planning of doing the radiofrequency. That is mandatory. Okay, so just I will giving you the how the radiofrequency works. First of all, what we do in the radiofrequency? Most of the times, we do the radiofrequency with ablation. Sometimes it is not ablation. I will talk to you later on. There is another type of radiofrequency which is not ablating, but mostly we ablate the node. So, radiofrequency is one of the options to have the ablation. Ablation of the nodes. Another very sophisticated term is your neurolysis. So, neurolysis, what is the definition? It's a destructive neuroablative procedure where we are doing the ablation of the nodes for the purpose of, mostly for the purpose of pain relief, but sometimes, particularly for the PMR people, also for spasticity. So, I can remember in our early days, that time Botox was or botulinum toxin was not that popular. So that time, mostly for the spasticity of the lower limbs, some of the motor nerves was ablated, and that helps us to reduce the spasticity as well. But nowadays, neuroablative procedures for the spasticity management is very rare. So mostly the neurolysis is done for the pain management purpose. And what are the other options to ablate now? One of the options is obviously the surgical options. You can open and see the nerve, or you can see the nerve endoscopically. That is nowadays again coming back, like radiofrequency of the medial branch, radiofrequency of the lateral branch of the sacroiliac joint. So other options nowadays become popular is your endoscopically you can see, identify these nerves, and you can ablate these nerves. So surgical ablation is one option. Second important option is basically the oldest one is your chemical neurolysis. We are injecting chemical and we are ablating nerves. The oldest one chemical is obviously alcohol, and still it is being used. Alcohol is one of the oldest one and still it is being used. Some of the indications are there where still alcohol is the first choice. Like if you plan to go for a celiac pressure block, the procedure of the choice is to inject alcohol there. The reason is in the other way you can have a very small size lesion. But when you are giving the large volume of the alcohol, you can have a large size lesion because celiac plexus is a big plexus where you cannot do any other procedures. So there the option is your alcohol. Then another the chemical neurolysis is your phenol. Phenol and alcohol indications are almost same. And another, still it is used in many areas, many centers, hospitals where the radiofrequency is not there, is your glycerol. Glycerol is one of the options for the Gacillian ganglion. That is only one indication for the glycerol neurolysis. Retrogacillian glycerol injection. So injecting glycerol in the Meckel scale where the Gacillian ganglion is there, and that can cause the ablation. And the fourth one is your hypertonic saline. Hypertonic saline is used only on indication. That is your adhesive lysis in a patient of the epidural adhesions following surgery, tailback surgery syndrome. The hypertonic saline, 10% hypertonic saline. Unfortunately, these are all theoretical for us Indians because 10% hypertonic saline is not available here. So what is done there is you're doing the adhesive lysis with some other options. Means mostly it is done by the epiduroscope or by the RAX catheter, and then after doing the adhesive lysis, the hypertonic saline is injected. And hypertonic saline, what it does, it ablates the finer C fibers without damaging the other important fibers. So that is another option. So these are the four chemical neurolysis still now approved and used. And other kinds of things are written in the history book. Not. There are many other long list of chemical neurolysis which are not used now. So currently these are the four important drugs are very used. Thermal is one, and another nowadays is becoming very popular is your cryoneurolysis. So where we are applying the extreme cold. Extreme cold means minus 80 degree temperature, and we are ablating the nerves. So these are the different options for doing. Okay, mechanical compression is another. Mechanical compression is used in again Gacillian balloon compression. Many of you must have heard it that we are placing a furnace catheter in the Meckel scale, and we are inflating the balloon, and that is compressing the Gacillian ganglion against the Meckel scale and ablating it. So these are the few options for doing a neuro ablation, and most popular of all those things, which are higher success rate, longer duration of action, is the radiofrequency. So if you are thinking of the neuro ablation for pain management, the number one choice is obviously the radiofrequency. So there are some disadvantages also. Most important disadvantage is your nerves cannot be seen. As I told you, most of the nerves cannot be seen. Sometimes with the ultrasound, today and tomorrow we will be doing some procedures under the ultrasound as well. But still, you can see the vessel there, you cannot see the nerve there. So that means the nerves are not visible, and when you are doing exclusively under the serum, you cannot see the vessels also. So, what is very important is you have to place the needle perfectly in the radiological landmark, and sometimes with the other landmarks as well. And if there is a failure, means if we are not placing the needle in the right place, then what is the outcome? Okay. So this has to be understood that radiofrequency procedure you have to develop the skill. I started that in the beginning, that unless you are well versed with the other interventional procedures, don't think of radiofrequency procedure. And second thing is the complications. As I told, that inadvertently damaging the other nearby nerves is one of the very important complications that must be avoided. And that is another reason why the some safety aspects are there. I will be discussing it when I will be doing the procedures there. That how to be safe to avoid other nerves. Initially, obviously, it is costlier, but in the long run, it is less costly because if you are thinking that radiofrequency is giving you pain relief of 2 years approximately on an average, and if you are calculating the cost and the suffering, definitely the initially costlier, but in the long run, it is not costly. And another important thing is your development of the diaphragm system. So many those who are very new in the pain management, they must not have heard, may not have heard the diaphragm system pain. Diaphragm system pain is when we are ablating a nerve, a peripheral nerve, which is a mixed nerve, where both the sensory, different kinds of sensory fibers are there. So this fiber starts regeneration if it is the second degree nerve damage. More than second degree nerve damage, still the possibility of the regeneration is there. Particularly the third and fourth degree, the regeneration will be there, but that regeneration most of the times becomes a faulty regeneration. Faulty regeneration means the two things happens. One is there will be the crosstalk. Crosstalk means one kind of fibers will be talking with the others. Say for example, A delta fibers is carrying pain, A beta fibers is carrying touch. So now if there is an exchange of signal between the A beta and A delta, then what will happen? It will be touching there and patient will be feeling pain, allodyne. So this is one of the very extremely bad complications. Second important thing is, this again happens particularly the fourth degree nerve lesion. So what will happen, that the sodium channels, you know that the signal in the action potentials are transferred by the sodium channels. And these sodium channels are manufactured in the cell body of the nerve, not in the axons or dendrites. So they are manufactured within the cell body. And then these sodium channels are basically proteins. All ion channels are proteins. Will be transferred distally along the axons and the dendrites to be distributed around the whole of the axons and dendrites. So now what will happen if you are ablating the nerve, particularly this ablation, if it is a third degree or fourth degree, particularly the fourth degree, then the sodium channel will be accumulated at the end where the damage has been done, where you have ablated. And that part, this happens also in the amputation also. So you are ablating that, the sodium channels, which is primed, which know that, okay, my axon is this much of length, so I have to manufacture this much of sodium channels, and that will be transferred distally. So now because there is a damage or because there is an ablation, so these sodium channels cannot go distally, so they will be all accumulated at the damaged end or the cartilage. And when there is an abnormally high density of the sodium channel, so there will be a virtual neuroma where the ectopic signals, spontaneous action potentials develops, and that can cause pain. So these are the two important complications or side effects of any nerve damage which is beyond second degree. Second degree means where the endothelium are intact. There is only axonotosis. Axons are lost, but the endotheliums are intact. Till this stage, the nerve regeneration will be perfect. But if the nerve damage is more than that, that means if the endothelium, perineurium, epineurium, these are damaged, then what will happen? All these complications, that means the complication of the crosstalk. So remember these two important things. One is crosstalk, mixing up of the sequence of the different afferent fibers, and the ectopic sequence. This might be complicating the procedure. That means when you are doing a mixed peripheral nerve, where the touch, different types of touch, pain, fibers, fibers are together. So these complications are very important complications. So what are the procedures where this can be seen? One of the very important areas is the gastrin ganglion. The gastrin ganglion, at least in 2% patients, the pain might be worsening after doing the procedures. Because as I told you, these are the important reasons that patient is developing these two, ectopic signals and your cross. So what will be their features? So initially, normally you all know that trigeminal neuralgia, patients will be, particularly we call it type 1 trigeminal neuralgia, idiopathic trigeminal neuralgia, where they will be coming in the episodes, it lasts about 2 seconds to 10 minutes, and then they will complete pain relief. But when this is developing, then what will happen? There will be always some baseline pain. Patient will not be pain free. All the time patient will be having the pain. And the pain will be having the other different neuropathic features. Means patient will be having the burning features, the burning sensations. Patient will be having some numbness also. So these are the other few features will be developed, and we will be telling us that the patients might have developed these conditions, which is called anesthesia delusion. The trigeminal neuralgia is called tick delusion. And these conditions, there is an anesthetic patch, and from that anesthetic patch, there is a spontaneous, continuous pain. So this is sometimes also called the type 2 trigeminal neuralgia. And this can happen when you are basically ablating or damaging the gastrin. So this is one of the bad complications of the trigeminal, the ablation of the gastrin. So the other areas where you do the ablative mixed nerve is your medial branch. Though medial branch, this incidence is less, medial branch, lateral branch for the sacroiliac joint. But this complication is not there when you are doing the sympathetic nerves. Because sympathetic nerves, they don't have any different touch or only pain fibers there. There is no touch fiber, no motor fibers. That means when we are ablating a lumbar sympathetic nerves, or we are ablating this splanchnic nerves, the striate ganglion, thoracic sympathetic. So in these areas, this will not happen. But the areas where the nerve is having the touch and as well as the nociception, that means this can happen in the other peripheral nerve abrasions as well. Means it can happen in the genicular nerve abrasions, it can happen in the articular joint, for the shoulder joint, hip joint, the facet joint. So in all these areas, this deafferentization complication, though it's rare, that's not very frequent, but still it can happen. So this is one very important complication. And to prevent this complication, one of the important option is not completely foolproof, but still will be reducing the incidences, is your injection of the steroids after doing the procedures. Particularly when we do the heat ablation, we always inject steroid before taking the needle out. How it helps? So steroid have the membrane stabilizing. We all know the steroid is an anti-inflammatory drug, but apart from being an anti-inflammatory drug, it is having a membrane stabilizing local anesthetic. So how it will be helping? It will be preventing the crosstalk, and it will be also preventing the development of the ectopic signals by virtue of its membrane stabilizing or local anesthetic. So that is the reason why whenever we are to do the heat ablation, we should be always giving little bit of steroids. Sometimes this is wrongly described as an inflammation of the nerves, but it's really not the inflammation of the nerve. It is basically the development of the deafferentization pain which can worsen the pain. So this is the deafferentization pain little bit. Now come to the radiofrequency. So first is why it is called radiofrequency, and again there are some myths regarding why it is called radiofrequency. Sometimes it has been explained, even I have heard this in some of the conferences, that it is called radiofrequency because there is no direct tissue contact, and it works distally. Like what happens in the radio means there is a transmitter, and I have a receiver, transistor, and I am listening. That means there is no physical contact, but I can still hear the music. So that is the reason why it is called radiofrequency. But this is completely wrong. I am telling you this thing so that you are not doing the same mistake in the future. This is not the reason why it is called radiofrequency. Then why it is called radiofrequency? Radiofrequency is called radiofrequency because the radiofrequency uses the alternating current. You must be knowing the alternating current and direct current. Alternating current means the direction of the current will be changing. And direct current means it is always from one pole to one electrode to another. So that is a direct current. So radio frequency is an application of the alternating current. And its frequency means how many times it is changing its direction is called frequency. Like in the household current, what is the frequency? 50 Hertz. Means each second it is changing its direction 50 times. But in radio frequency, what will happen? There the input current is 50 Hertz because I am taking this connection from my, the plug here, household and domestic current. But machine will be converting it into a high frequency current, 300,000 Hertz. And this 300,000 Hertz is a frequency which matches with the frequency used in the radio wave transmission. So radio wave transmission's frequency band range is similar to that what we are using here, and that is the reason why it is called radio frequency. So don't think that it has nothing to do with radio transmissions or anything else. So here the frequency what we are using is similar to that. So now few other things about the electricity. Electricity is having one already told alternating current having frequency. Direct current don't have frequency. Alternating current is frequency. The direct current do not change its direction. It's always from one electrode to another. Alternating current, one electrode and positive and negative, they are alternatively changing. Then comes volt. So what is volt? Volt is the potential difference between the two electrodes. Current will be passing from one electrode to another electrode. So what is the potential difference? So if the potential difference is more, the flow of the current will be more intense. There is ampere. Ampere means what is the flow of electrons or flow of current. So voltage and ampere, they are proportional. The more will be the voltage, so more will be the ampere. Then is here watt. Ultimately, watt is the most important part. Means if you are talking about the strength of the electricity, it is expressed in watt. And watt is the multiplication of the voltage into ampere. Right? So remember these three things. Voltage is the potential difference. Ampere is the flow of the electricity. The rate, the current. And third one is the power. And power is your multiplication. Another important thing is there which I forgot to mention here is your resistance. Resistance means how is the conductor who is transmitting. So ampere again depends on how much is the resistance. So more will be the resistance, less will be the ampere. And this resistance is also important when you are doing the radio frequency, because when we are having the resistance very high, what will be the very high resistance? If we have your electrodes, we are placing the electrodes there, nearly electrode. So in an area where the electrolytes are very less electrolyte, like say for example we are putting it into some tendon or we are putting in some capsules, these are the very less vascular rate or periosteum. So what will happen that the resistance might be very high. So very high resistance and very low resistance. When it is a very low resistance, particularly when we are putting it in the blood vessel or we are putting it into the interthecal CSF, so that the resistance will be very low. So neither of that is acceptable. So the best range of the resistance is some resistance which should be acceptable is somewhere between the 150 to 400. Up to 700, 800 also things will work. But most of the machines which are sophisticated machine, if the resistance is beyond this limit, it will not work. It will stop working. You cannot start the machine. Start the listening, not machine, start the listening, unless your resistance is in a desirable range. So desirable range by the size of the lesion is maximum. Because why it is important, as I told you, that resistance is influencing the ampere and the power depends on voltage into ampere. So if ampere is too high or too less, depending on the resistance, then your appropriate size of the lesion will not be there. The desired size of the lesion cannot be reached. And that is the reason why the resistance must be in the proper range, which should be somewhere between the 150 resistance unit of the resistance you must be knowing ohm. So 150 to 400 or 450, this is the range where the resistance will be there. Otherwise, many times we have seen that we have pressed the needle and radiologically it's fine, absolutely nicely placed needle, but still it is not listening, it is not starting this. The reason is the resistance, you look at the panel, you see the resistance. Resistance must be very high or very low, then the machine will not start. So then what you have to do? You have to reposition the needle. And if the resistance is too high, then what you can do is you can inject a little bit of local anesthetic or a little bit of saline. So that will be again reducing the resistance to your appropriate area. So that is another option without moving or repositioning the needle. Because repositioning the needle is sometimes difficult because the needle should be very close to your target, close to the knob. And if you are repositioning the needle, you might not be getting the proper stimulus. So I will come to the other part later on. So now the principle, what is there? As I already told you, the machine receives electricity whose frequency is how much? 50 Hz. And machine's output current how much? 300,000. So machine is like that. Input current and output current. Output current frequency is 300,000. So now how will it work? So when we are putting this electrode in a live patient body means lot of differently charged atoms. Some are positively charged, some are negatively charged, and some are neutrals. So what will happen? So the ions around that electrode will start oscillating, will be charged moving. So positively charged will be going towards the cathode or anode. In that way it will be moving. But here what is happening is not direct current. That means current is not moving from one direction to the other. So here the changing. So the charged ions will start moving or better called oscillating. But it will be oscillating at which rate? Depending on the frequency of the alternating current. That is movement or the oscillation of the charged ion will be at the same frequency of the alternating current. So what is the frequency here? 300,000 Hz. That means these charged particles will start oscillating at 300,000 times per second. So it will cause the friction with the oppositely charged ions or neutral ions. And what will happen? That is going to create heat. So that is how it is getting. So what is important here? That electrodes themselves are not equal. So which part is it? The charged particles, which is causing the friction with the oppositely charged or the neutral ions, they are getting it. That means tissues are getting it. So this is how the heat is affected. And another very important thing is that the more is the frequency, that means here where you are using the radiofrequency, then the lesion size will be more precised, small size lesion. So what is the size of the lesion? Size of the lesion in the conventional thermal radiofrequency is somewhere between the 2 mm to 4 mm around there. Okay? So what is happening here? So you are putting one needle there. Needle means the radiofrequency cannula we call it. So it is like a needle with a slit. Its whole part is insulated except the tip. An exposed part which is not insulated is basically the size or shape of the electrode. So that size of the shape of the electrode can vary. We can make it from 2 mm exposed tip to the 15 mm exposed tip. The size of the length of the electrode varies from 2 mm to 15 mm. White, again, it can be available size is from 22 gauge needle to 14 gauge needle. They are the different size of the electrode shot available. So what will happen here? That when we are putting the radiofrequency radiofrequency with the probe within that cannula, then what will happen? The electrode will start like this, acting, and the ions around it will start moving. And the size of the lesion will be very much precise size of the lesion around that electrode. Then this is a circuit. So as you can see in the machine, that there is a machine or the input current is your how much? 50 Hz. And output current is how much? 300,000. So the area where the patient is having the So this area, where the ground pad is there, is a large area. So what will happen? The electricity will be dispersed in the wider area and that will not produce any lesion. So the lesion will be around this part, where the needle electrode is a small one. So how small it should be to have the lesion, and how big when it is bigger, there will not be any lesion. So if it is more than electrode length is more than 15 millimeters, that means 1.5 centimeter, then the electricity will be dispersed in a wider area and will not be having lesion. That means the maximum length of the needle what you can do is your 15 millimeters. As I already told you, the length of the lesion varies from 2 millimeter to 15 millimeter, and the width of the lesion depends on which gauge of the cannula you are using. So available gauge of the cannula from 12 gauge to 15 gauge. Then one very important things to remember, that when we are doing the, this already I have mentioned, that the size of the lesion around is your 2 to 4 millimeter, and the tip temperature in conventional radiofrequency is kept somewhere between the 65 to 90 degree, which can give you the best side of lesion, which is at the nerve will not be degenerated further quickly. So the temperature versus degeneration is almost proportional. If you are keeping a lesser temperature, that means the patient will be having the recurrence of the pain faster, means degeneration will be faster. And if you are giving a little bit of higher temperature, then the recurrence will be less. So now, this is again very important question. How the tip temperature is controlled? That means, otherwise what should happen? The more and more it is, moving, and the temperature will go on increasing, but that should not happen. More temperature means there is a more chance of what? As I told you just now, the degree of the lesion is proportionate to the temperature what we are using. So what is our option? We don't want 5th degree. Why? Then there will be more chances of what? Ectopic signals in the diaphragm center. Our option is to have a 3rd degree lesion, not even 4th degree, but 3rd degree and 4th degree it is very difficult to differentiate. Mostly we are getting either 3rd or 4th, mostly we get the 3rd degree. But if we are hitting it with a very high temperature, say for example 100 degree, so what will happen? There is charring of the tissues, and that is surely going to produce a diaphragm center. So we don't want that. That means our tip temperature should be in this range. I told you, the most the author uses or publications uses 65 to 80 degree, not even 90. But some authors uses 90 degree, but mostly the recommendation is 65 to 80. In this range, the 3rd and 4th degree lesions will be there. 3rd degree lesions will be there. So now, question is, how the tip temperature is controlled? So in the conventional radiofrequency, as I told you, that the most important part of the electricity is what? The wattage. So the wattage is the strength of the electricity, and the temperature what is created is proportional to the watt. So if you are giving more wattage for a longer time, what will happen? The temperature will go on increasing. But if you reduce the wattage, the temperature again will fall down. Okay, because body has its own, vessels are there which will be dispersing the temperature. So continuous, the cooling mechanism are there inside the body. So to overcome that, the heating should be appropriate so that the temperature is reached there. But once the temperature is reached there, then what you need to do? That our wattage should be coming down so that the temperature is also coming down, not around it. But if you are bringing down the temperature, what is going to happen? Temperature also will come falling down. So again, what will happen? Again, the wattage will go down. So this fluctuation of the wattage, today when we do the procedure, I'll be asking our camera people to focus on the this wattage part. We'll see that the wattage is not constant. You yourself is not fixing the wattage. Machine will be deciding what wattage is important to keep the temperature fixed at that level. That means if you are fixing the temperature 80 degree, once the 80 degree temperature, so initially you will see what was the wattage will be gradually increasing, and the temperature is also increasing. Now once the desired temperature is reached, say for example if I am fixing it at 60 degree or 65 degree or 70 degree, so what will happen? Once that temperature is reached, then the wattage will come down. and temperature will also have a tendency to come down. But again, the wattage. So that means wattage will be fluctuating to keep the temperature at a constant. So this is how the tip temperature is controlled by the condenser. But with this, what we are compromising? We are compromising the size of it. That means if the wattage, as I told you, wattage is determining the temperature, but at the same time, wattage is doing another very important thing. It's the size of it. That means more the wattage, more will be the size of the machine. So if we are to control the temperature, if we are reducing the wattage, what we are compromising? Size. Because we don't want the temperature to go very high, but we want to have a very large size listen. So there is another very important option that is called full radiofrequency. I am coming to that pulse frequency later on. First, let me tell about the full radiofrequency, then we will come to the. So what is done here? So here, within the cannula, there will be another channel, and through which the water will be passing, water at room temperature, and that will be taking away the temperature. So now, if that circulating water is controlling the temperature, there is no need of controlling the wattage. We still can deliver wattage at a higher electricity at a higher wattage. So in that way, we can have a large size. But again, it should not be very large, so that nearby structures are damaged. So the full radiofrequency, this is the very important unique thing about the full radiofrequency, that here the temperature is not controlled exclusively by the wattage. Still is a factor. It's not that the wattage is not fluctuating. Wattage is also reduced. But along with that, the most important, the option, most important mechanism of keeping the temperature at a constant level is your circulated water. Right? So this is how you can have a bigger sizes. Now coming back to the pulse radiofrequency. So what is pulse radiofrequency? Pulse radiofrequency, as the name suggests, you can understand that the high frequency current is used in pulse. That means 300,000 frequency electricity is given in small packets, and in between there will be silence, no electricity. So what is the advantage here? Advantage here is that we are not allowing the temperature to rise beyond 42 degrees Celsius. What is the advantage? So in that way, we are not allowing any heat lesion to happen. That means we are not damaging the nerve. So it is very safe. But the question is, if we are not allowing the temperature to rise, then how it is going to be effective? I told you at the beginning, there is a procedure which is not neuroablative, but still will be having some effect. So now there are controversies about how it works. A lot of mechanism has been suggested, and still now the mechanism which has been little bit accepted, not widely accepted, but still some the justification is there, and proved also by some of the studies that we know that there are different kinds of interleukins there in the body. Some of the interleukins are pro-inflammatory, it increases the pain, like in the rheumatoid arthritis and many other things. That some of the interleukins go very high, and there are certain interleukins which are anti-inflammatory, reduces the pain. So some of the studies shows that this pulse radiofrequency, that means here temperature is not fixed, but okay, I forgot to mention another very important thing. So if you are applying the current, alternating current with very high frequency, one, I told you how the temperature is rising, but there is another important effect of it, which is called electromagnetic field. So when the current is developed passing at a very high frequency, there is strong electromagnetic field will be developed around that. So the pulse frequency, how it actually appears. So when this strong electromagnetic field presence was, the proof that whether the current is passed at a very high frequency, there is strong electromagnetic field there around the electrode. So then scientists thought, can it have some effect? And that is how the pulse frequency. So what happens? This strong electromagnetic field basically is not a neuroablative procedure. So how it works? It stimulates some of the genes to produce some of the proteins inside the body, including the interleukins. Interleukins 10 or some other interleukins I forgot, which is having the analgesic. So this is one of the important mechanisms by which. But another very important thing was proved by some of the other experiments that there was the seeds soaked in the water. What will happen? It will be germinating. So now, one bowl, it was kept like water and seeds, and another bowl, the pulse rate frequency was applied. And what was seen that the pulse rate frequency helped in germinating the seed much faster than the control. So pulse rate frequency can fashion the different, the genes to be expressed and to do the things faster. So as I told you, still it is a the mystery that how pulse rate frequency works. But some of the study proves that probably it is having some neuro or other stimulatory effects rather than condition. So as I told you, what is done here? Pulse rate frequency. So here current is passed in a small packets. So what is the frequency of that current? 300,000 Hz. But what is the duration of each packet? It varies. The most machines has this default setting, and we call it as 2 Hz 20 millisecond pulse rate frequency. What is the meaning of that? That each packet, that means from here to here, this is your 20 millisecond. And 2 Hz. 2 Hz means 2 times per second. That means such current is given in 2 times in a second. So here this is 1 second. From here to here is 1 second. And current is given once here and that here. Each one is 20 milliseconds. And 1 second is how many milliseconds? 1000 milliseconds. So 1000 milliseconds, we are given 20 milliseconds 2 times. So how much? This is one of my very favorite questions in mathematics. So how much is the silence then? 960. And for between the 2 pulses, what is the silence? 480. That means 1 burst or 1 packet of your high frequency current, and then that is for 20 milliseconds. And then how long is the silence? 480 milliseconds. And then again 20 millisecond current, and then again 480 millisecond silence. So this way it goes. But as I told you, you can change it. Related to the machines, you can change this. Means you can make it 10 millisecond, 10 Hz. 10 Hz, 10 millisecond, the pulse rate frequency. So can you tell me what will be the silence in between the two? 10 Hz, 10 millisecond pulse rate frequency. What will be the silence duration between the each active current? 10 Hz. 90. So 10 Hz means 10 times your. So divide 1000 by 10. That means each cycle is of 100, and out of that 100, so 10 millisecond is the active current. That means 90 milliseconds. So understood how pulse rate frequency is given, and pulse rate frequency do not update, so it is very safe, but it is a very high frequency rate. So pulse rate frequency has been tried in so many indications, so many, more than 100 indications. Everywhere there is pain, and it has been tried. And in only few areas it has some. The most important area where it works is your dorsal root ganglion. So dorsal root ganglion is the only one now evidenced indication for the pulse rate frequency. In all other areas, pulse rate frequency has been stopped, and some areas it is replaced by the track. Means the heat ablation cannot be done. Say for example, you are doing it in a mixed peripheral. Mixed peripheral means, say for example, we are doing it in a, I'll be showing you when I'll be doing the shoulder. So mixed peripheral nerve earlier, the one of the very important option was suprascapular nerve pulse rate frequency earlier done. but it is having a very high field. Nowadays it is not done. Nowadays we do the thermal ablation. I will show you that. Where the muscular branches are left. Then you can, apply that there. So I will show you two shoulder cases are there. So but earlier option was possible. Another option is your cryo, like occipital. One of the still option is your pulse rate. Pulse rate is some areas, as I told you, some evidences are there. One is your occipital now, one is your intercostal now, one is your suprascapular now, and another is your dorsal radius. But out of these four important indications on the pulse rate, only one indication is still having the best evidence is your dorsal radius. The other is particularly intercostal, the occipital, and the suprascapular. So these are pulse rate frequency nowadays not done. For the shoulder, the best is your cool rate frequency once the articular, once the muscular branches are in the shoulder. And for the occipital and the intercostal, is the cryo, which is the better choice than the rate frequency. So pulse rate frequency, the indication is your what? So the conventional pulse, I'm just quickly speaking cool, I will told. Now we come to the bipolar. So what is bipolar frequency? So this part is not there. Means here the electrode will be passed, the current will pass between the two electrodes, which are kept very close. And if it is kept very close, what will happen? Just two small needles with exposed electrodes. The current will pass between these two. So both will be creating relation. And when you are putting it together, it will be having a larger size. So this is another option to create a larger size. But here the problem is there. What is the problem? That means suppose this is one needle. What is the shape of the lesion? This I forgot to mention. In a condenser frequency, the shape of the lesion will be cylindrical like this around the sand. So if you are putting two electrodes, the shape of the lesion will be like this, and basically it will be a dumbbell lesion like this. But in contrast to that of the cool rate frequency, what is the shape of the lesion? If the needle is there, it will be a spherical lesion like this. That means here the needle to be placed independent of the angle. That means suppose if the nerve is here, if you are doing the condenser frequency, how to place the needle? Like this. So that you are having the lesion like this and you will be having the more larger contact period. That means here the principle is try to place the needle as parallel as possible, but never perpendicular. If it is perpendicular, what will happen? Your lesion is here and your nerve is here. So very small contact area and very high chance of failure. That means in facet joint, in sacroiliac joint, in many other areas where we are doing the condenser frequency, your needle angulation should be such that it is as parallel as possible, not never like this. If you are doing like this, failure is certain. But for the cool rate frequency, this is good, this is good, this is good, because ultimately it is a football size lesion. It is a spherical lesion. So it is angle independent lesion. So if it is a lesion like this, whether you are placing like this, doesn't matter. So that means this is another very important area. Even though bipolar frequency is causing the larger size lesion, but still it is smaller than the cool rate frequency. And another important thing is there will be no lesion beyond the needle tip. So lesion all will be there between the two electrodes and little bit around it. But the beyond the tip there will be no lesion. So anyway, bipolar frequency has certain advantage in one or two areas. Particularly the most important area where the bipolar frequency is very effective is the coccygodyne. When you do the ganglion impulse block, so what do you do? We put two electrodes, one between the S5 and coccyx1 and another between coccyx1 and 2, and the needle will be the two electrodes and it will be having the lesion in between these two, and basically the nerve is in between that. The ganglion impulse is situated in front of coccyx1. So that will be very nicely applied. That is one of the area where the bipolar frequency, in my practice, I still do the bipolar frequency for the coccygodyne In other area, I don't do the bipolar difference. Then is your multi-channel. What is multi-channel? Multi-channel is, here it is shown the 2 electrodes, but it can be 4 electrodes as well. So one ground pad will be there, but then the current will be what I have seen in the bipolar, that these don't have any function. So here the current will flow between these two. But in the multi-channel, current will flow between these two and these two. If it is another electrode is there, then this. If another electrode is there, then this. So current will be flowing between the ground pad and the electrodes, not between the 2 electrodes. So what is the advantage here? Advantage here is, at a time, we are not wasting time, because each time you have to approximately 2 minutes. You have to wait. So one, you will take long time. But if you are having simultaneously all the engines are put together and then you are doing the listen, so that is the biggest advantage of the multi-channel. So multi-channel is more costlier, but each one circuit is between the electrode and the ground. That is multi-channel. And bipolar, the ground pad has having no functions. The current is flowing between the 2 electrodes. Now these are the different RF cannula. As I told you, starts from 22 gauge, and the diameter is here 32 gauge, 0.64 millimeter. And when you are using 14 gauge, diameter is 1.63. That means if you are using condenser frequency, one of the options to increase the size of the laser is what? Taking a larger gauge. If you are taking a larger gauge, automatically you are getting 1 millimeter extra listen size, because maybe itself is causing the listen. And the length of the listen, the length of the electrode, it varies from 2 millimeter to. Okay, one thing you remember, tomorrow we will be having an evaluation. In all our courses, we don't award certificates. Those who have done, that certificates will be awarded only when somebody is securing 50% marks. So tomorrow, whatever we will be discussing here and during the classes, based on that there will be some multiple choice questions. We will show it here by online, by Kahoot. We will be answering those questions, and then we will be going. So what I was going to tell you, that listen size increasing, there are several options. What are those options? One of them was using the bipolar radio frequency. One of them was using the pool radio frequency. Another, what I am discussing here, using a larger gauge. If you use a larger gauge radio, you will be automatically having at least 1 millimeter larger size listen you can get. Apart from that, there is another important option is using the carb radio frequency. So carb radio frequency, what are we doing? So needle is turned on one side. So now after doing one cycle, if you turn it to the other cycle, what will happen? The size of the lesion will increase. So that is another way to increase the size of the lesion. That you will be doing, instead of doing one cycle, you will be doing 2 or 3 cycles, and each time you will be turning the needle. But one very important thing is that you never advance the needle. Why? Because if you are advancing the needle, you have tested everything. Now I will tell you how to test before doing the lesion. So you have tested everything, you are very much sure that my needle is appropriately placed, but at this time you give the local anesthetic. Because hit listen is very painful. You have to give the local anesthetic and then only you can start it. Once you are giving the local anesthetic, then you cannot stimulate the nerves to understand whether you are inadvertently closer to the nerves. So once you are giving the local anesthetic, don't push the needle forward. But what you can do is, you can turn the needle to the other side to have a larger size. Then there are different types of cannula. One cannula is called the protruding cannula. So what is happening here? After pushing the needle, there will be one which will be protruding, and basically it is going to like 2 electrodes, but it cannot be too much heavy. Then it will not work. So the protruding electrode will be giving a larger size. Then venom cannula, it will be bifurcating. While pushing the needle through the skillet, it will be bifurcating. So this is your venom cannula, and this is your trident cannula. So it will be bifurcating, and here will be the 3, the king will be divided into 3, and will be having a larger size. So these are the different cannulas, newer cannulas with which you can, once you are placing the needle, after that you can push the skillet and you can have a larger size listen. But again, the best option to have the large size lesion is, there is a study which is comparing that even using the needle, the newer cannula, you can have a larger size lesion, but still the cool radiofrequency probe gives the largest size lesion. These are the different shape of the lesion. Another important option to increase the size of the lesion is your doing it for the longer term. But again, the curve is not proportional. So initial time, this is your time versus size of the lesion. Initially, it is almost proportional. That means when you are increasing the time, the lesion size increases, and then gradually there will be a plateau. And after some time, the rise of the size of the lesion is very minimal, and it has been seen that after 2.5 minutes, there is almost no rise. That means, you see, initial 60 to 90 seconds, your lesion size is always increasing. That means the minimal time of the lesion recommendation is your 60 seconds. Because after 60 seconds, the rise of temperature, rise of the size of the lesion is minimal. And the maximum is 2.5 minutes, because after that, there is no appreciable rise of the size of the lesion. So, what is important, what is the bottom line from this slide is that do not start and stop. So time also going to increase your size with a limitation that after 2.5 minutes the lesion size will not increase. But the duration should never be less than 60 seconds. Because up to 60 seconds there will be always appreciable rise of the size of the lesion. So, here the summary: increase the gauge, increase the time up to certain level, use of the cool radiofrequency, use of bipolar radiofrequency, use of newer cannula like Venom cannula, like the Trident cannula. You can also have a similar size lesion. Now, how to confirm that you are in the right position? As I told you, this is the most important areas and where you need to have the experience as well. So, one is your obviously ultrasound guidance and CR guidance. So, CR guidance, how you are placing it? We know that CR how we are going to see. We are going to see only the mode. So, we know that we have to remember the anatomy, that the nerve remains here in this area, in that part of the mode. But again, there is always, and we can also, as I told you earlier, that the USG is little better than the CM, because USG can show the blood vessels and expecting that the nerve will be closer. But again, ultrasonography is not possible everywhere. Like in gastric ganglion, you cannot see the gastric ganglion on ultrasound. So it has to be exclusively CR mount. Second important part is again very important, the sensory and the motor testing. Sensory testing is what we are doing. We are delivering the current at 50 to 100 Hz. So what will happen? The sensory fibers will be stimulated at this frequency. Motor fibers will not be stimulated at this frequency. So remember, there is a rule that the lesser the frequency, the larger diameter fibers will be more stimulated. That is, motor fiber stimulations can be done by the frequency range from 1 to 10 Hz. Mostly we give 2 Hz. And sensory fibers, smaller diameter, smallish diameter fibers up to 100 Hz. So, what is important? Our needle should be how much away from the electrode? Maximum 4 mm. If it is more than 4 mm, there will be no lesion. As I told you already, why? That the size of the lesion around the needle electrode is how much? 2 to 4 mm. So, if our needle is away more than 4 mm, there will be no lesion, means no nebulisis. Lesion is still there, but there will be no lesions of the desired nerve. So, how to know that I am close to that nerve? Because you cannot see the nerve and there might be anatomical variation. So, what do you have to do? You have to do sensory testing and motor testing. So, sensory testing, what do you do? We deliver the current and ask the patient. Sensory testing is more important. So, ask the patient, are you getting paresthesia? Some tingling sensation, some tracing sensation, some feels pain also. Like, when you are delivering the current at that, is it when you feeling pain? As well as pain fibers also existing. So, we are asking these questions and we will be making the switch off and on. Switch off means, because needle tip itself also has some pain. So, they have to understand, when you are making it on, then that time is feeling pain and reduced when the patient is off. So, by that way, by sensory stimulation, we have to understand. But most important is your paresthesia. Some tingling sensation is more. But many times, patients do not complain of paresthesia, patient complains of something, some pressing or compressing pain. That is also accepted. And that should be there when the voltage of the current is your how much? Less than 0.6. That means you are within the close vicinity, within the 2 to 4 millimeter. If it is 0.3, 0.2, fine, but it should not be less than 0.2. Why? That means you are touching the nerve. Touching the nerve is sometimes can be difficult, particularly those who are anesthesiologists. They know these things. That touching and piercing the nerve is not recommended. Here we are ablating, so may not be that much important. But sometimes in some areas, when particularly you are doing the pulse frequency, we must not touch the nerve. That means the best option to have the sensory stimulation is somewhere between the how much? 0.2 volt to 0.6 volt. If it is increasing the voltage, even if your needle is away from your electrode, if knob is away from your electrode, even then you might be getting the sensory stimulation. But that is not desired. Suppose you are stimulating in a very high. So, even the knob is 1 kilometer away, then also this might be getting the stimulation. So, you have to reduce it below what? 0.6. But sometimes, so if not, what you have to do? Reposition the needle. But sometimes even after repositioning, you may not be getting the. So how much is the uppermost limit, acceptable limit? Is your 1 volt. Don't do the procedure if you are not getting the sensory stimulations beyond 1. But best results are always below 0.6. So always try to stimulate below 0.6. This is mandatory, almost important. If you don't have, don't do the procedure, because you know that you carry your receiver. Then is your motor testing. Motor testing is done between 1 to 10, I told you. Mostly it is done by 2 hertz. Most of the machines is having the default setting of 2 hertz. So what you are going to get? Suppose you are doing the number system. So what is the relevance of the motor testing? Is there any modifier in the number system?
No.
So number system they don't have any modifiers. So there will be no. So the motor testing has 2 important relevance. One is if that particular knob have a motor fibers. Say for example, we are doing gas landing. So we are having the mandibular and very close and specifically having the massive contraction. So you will be happy that the massive contraction is there. If you are doing the facet joint, medial branch, it supplies the multifidus muscles. So if there is a multifidus contraction, you should be happy. But suppose you are doing the facet joint and the leg is dancing, will you be happy?
No.
So that means you are inadvertently close to other nerves, which is not required. That means motor testing has 2 important values. One is because motor nerves is very important. We cannot, at any cost, we cannot avoid the motor fibers. So some motor fibers you have to sacrifice like multifidus. If you are doing the medial branch, you have to sacrifice the multifidus. Multifidus is a why is multifidus muscle? Between the one lamina and another lamina, it is the medial most part of the erector spinal cord muscles. Remember here, the 3 important erector spinal cord muscles. One is multifidus, other is convolucimus and multifidus. Multifidus is also called the medial most part of this erector spine. It is very small muscles. Even if you can sacrifice that. That means when you are doing the medial branch block, so we are basically ablating the motor supply of the multifidus. But we are not bothering because the other extensors are there, the other erector spinal muscles are there, so we are not bothered about it. So if you are getting the multifidus contraction, when you are doing the medial branch block, you should be feeling happy. And this contraction of the multifidus should be at a lower voltage, below 0.6. Okay? But now, you should be still going to increase the voltage up to 2 volt. And you have to notice that there is no contraction of the other important muscles, particularly when you are doing in the lumbar spine, that we are not stimulating the nerve roots. So there is no contraction of any of the leg muscles. So that means the lower voltage should stimulate your nerve, which is supplying, having the motor fiber sometimes, and the higher voltage, to be sure that you are not inadvertently to the other levels. Though 2 voltage is not going to create a lesion, that still up to 2 voltage is the standard to be sure that if you are increasing the voltage to 3 volt and still getting the leg contraction, you need to do it. Because up to 2 volt there was no leg contraction. Because as I told you, if you increase the voltage, even if the nerve is away, even then you might be getting the stimulation. But if it is 2 volt is the upper limit. If you are getting stimulation beyond the 2 volt, that means your needle is too away, that is not going to create any lesion to that particular nerve. But if it is below 2, it is plus minus, may or may not be. And lesion is certain when it is below 0.6, below 1, also there might be a little bit of lesion of the neural system. So this is how we are going to confirm the needle placement, that my needle is close to the normal, and that is going to be a function. Then these are the indications, and most of the indications what we will be showing you today. Bhaskar will be here, and he will be giving the coordinates. So when you will be having any questions, any doubts, we will be talking from the OT and putting the questions. And because this batch is bigger, so initially our this small group, we normally do it allowing all the participants inside the room. So here we cannot. So what will happen? Rajiv, I am giving this responsibility. Who will be going? Total, the 6 procedures will be there. So in batches, 2 or 3 people can go inside the OT. More than that, it will be 1 hour. And because recordings also will be there, and recording will be uploaded, and the links will be given to all of you, so that you can whatever the procedures you are seeing, you can. So the 2 camera, the knee testing as well as the image what will be there transmitted, and any questions you can ask. Okay. And not a long big procedures, because each procedure will be taking ample of time to answer all your questions. And after that, there will be a small break. I'll be coming here and I'll be answering your question before going to the next procedure when it will be ready. By that time, we can continue the exercises. Okay. So first procedure is your gasoline tank. So from your side, decide 2 to 3 will be done, and you also 1 people, 1 person come to class. And Bhaskar will stay here, and you just coordinate the connections between OD and. Okay? If you have any questions regarding what I have discussed right now, you can ask.
So you told different ways to increase the size of lesion. Even local also can increase.
Even local?
Yes.
No, that is not a
lesioning size.
Local or normal saline is given when I told you. When suppose even after the reposition of the needle, if your resistance is very high, to reduce the resistance you can do that in the but local anesthetic always to give it, always has to be given, because the heat lesion is always painful. So you have to always give the local anesthetic before doing the procedure. But that is nothing to do with the size of the lesion.
The indications of conventional RFP then.
The most important, what is the difference between the cooled and the conventional? As I told you, one is a small size lesion. Cooled RFP is having the large size lesion. Second important is conventional frequency. The lesion will be along the shaft. Cooled, it's a spherical beyond the tip. So now, if you are keeping these things in your mind, you can understand why it should be done. Like say, for example, where the small size is needed, large size is bad. Large size is not required. Why? One of them is here, gasoline. So gasoline always the standard conventional frequency. Never think of the cooled frequency. Okay. So what are the other indications? Again, though in the cervical earlier it was thought that it will be the conventional, but nowadays again cooled frequency has two bit safety there. But still, more studies are needed. And if you are trying to do your lots of again pulse or sometimes conventional. So conventional frequency is where you need a small size lesion. And large size lesion advantage is you will be able to catch the nerve even if it is little away. Number one is angle independence. It is easy to do. You can do it at any angle. You can do perpendicular. Because most of the times, most procedures are best done by the tunnel vision. Means, suppose it is there, they are putting the CM like this, and your needle is seen as a dot. Turn the patient over the bone, and it can be done only if it is a cooled reflex. You cannot do under the transmission if it is a conventional. So conventional and cooled nowadays, whole world is going towards the cooled reflex because except for one or two indications, the conventional reflex is basically replaced by the cooled reflex. But still, while you need a small size patient, conventional is the choice.
Bipolar reflex.
Bipolar only one indication I told you.
But that we do with conventional.
Bipolar can be conventional, bipolar can be even cooled. Like biarthroplasty is a bipolar cooled disease. So conventional, as I told you, what is the advantage? That it will be in between two. There will be no lesions beyond your needle, and where the ganglion is between the two needles, that is the area where the lesion is.
So in DRG, if you go for conventional, then more chance of motor power safety.
Conventional difference, thermal lesion is not done, as I told you, pulse difference is not done. But some papers are still there. But we have to stimulate it to know that you are away from a motor. Cervical, as I told you, conventional is the standard still now, but the recent evidence even the is very effective and better than but most studies are related. But still now, as of now, if you are asking me what should the cervical, it is your conventional. Because nearby structures are there.
We have been on prostate. To be more with conventional like
same as any thermal lesion. If it is a cooled frequency also, if it is a bipolar